Hello, everyone. Thank you for your time here. You can see my screen already, right? Yes, screen sharing. So my name is Cristina. I am product manager for the optical business. And in similarity to my fellow presenters, I will first start with telling you who HBK and HBK FiberSensing is, and then we go into the product that we are presenting here today. So HBK FiberSensing was created first as a spin-off, only FiberSensing, more than 20 years ago. And a company that produces and develops fiber Bragg rating-based measurement systems. So for test, for measurement, and for monitoring. So FiberSensing was then acquired after 10 years of existence on its own. It was acquired by HBM, so a big company based in Germany that already had many years also of existence and traditionally known for their conventional strain gauges, so resistive strain gauges. They were already exploring some solutions based on fiber Bragg rating, and they decided to acquire FiberSensing. It was a very good match at that time. Then the company grew, and in 2019, the HBM merged with Bruel & Kjær, which is another old European company from Denmark that produces mostly accelerometers and microphones, so more to the frequency domain of the measurements. And it made sense for the two companies to become one. And so that happened a few years ago. And this is how HBK FiberSensing appears in today's world. So we are located in Porto. This is where FiberSensing was created, and all of our development and production activities are done. But thankfully, we rely also on the global presence of HBK through their own offices around the globe or through distributors as well. So it's also very good to have this local presence. So if you are not in Portugal, it's always good to have someone that talks your own language for the opportunities that may arise. So I think that this is a very good thing. So if we start with the product that I am here promoting today, so this is an accelerometer, so a sensor to measure vibration. It is called a high sensitivity accelerometer, so to get big insights out of very subtle, very small vibrations. This was the gap that we had on our portfolio that we tried to fill with this sensor. So this sensor is based on the New Light technology. New Light is a product line from FiberSensing, from HBK FiberSensing, that combines several technological aspects of the fiber, on the coatings, on using femtosecond FPGs for ensuring longevity on our solutions, on our measurement solutions, and also compatibility throughout our full portfolio. The biggest innovation on this sensor is the high sensitivity that we managed to achieve. So we are using the fiber Bragg rating technology for measurement, so watching the fiber Bragg rating peak changing and measuring the wavelength variation. Here we are able to detect per G 1,300 picometer variation. So this is the sensitivity of the sensor, and that in combination with performing interrogators can allow us to make measurements as small as 10 micro G. So very interesting for very small measurements. This is true throughout its also frequency operating range. So we have the sensors designs for measuring plus minus 2G or plus minus 5G, and this throughout a frequency range or with the same sensitivity from almost 0 to 75 Hertz. So this ensuring a 10% flatness. But as you see on maybe it's a bit small, but as you see on the peak, it's possible to measure. So the resonance frequency stands at 240 hertz, and we can measure up to 100, maybe with a slightly higher level, but also still under a very good result level. Then we are using 2 fiber Bragg ratings to ensure long-term stability and compensate for the effect of temperature on the fiber Bragg rating and on the sensor itself for a seamless operation between -20 and 80 degrees C. And also another interesting characteristic is that it uses dual fiber. So the fiber Bragg rating, as you might know, can be measured from both sides of the line of the fiber, and the fact that the sensor has the 2 lines allows for the assembly and connection with other sensors. Could be assembly in biaxial or triaxial configuration, could be combination with other sensors and other measurements based on the same fiber Bragg rating principle. So this is a very interesting sensor developed with the focus of applications in structural health monitoring, namely on vibration monitoring. So I would like to share with you where we use this type of sensor. So as mentioned in vibration monitoring, for example, using it for ambient vibration and for model analysis of bridges. So when you have big structures that are very stiff, you have very small frequencies on the vibration modes, and you have also very small amplitudes of this acceleration. That's why you need the high sensitivity to detect it under this ambient vibration. So it's also possible to perform tests with excitation on the bridge, but those are more difficult, and the ambient vibration is a very good way to assess the structural health of the structure. Then it's also possible to use, for example, on the determination of tension on cables, so also with the purpose of structural monitoring. The tension on the cables is proportional to its vibration properties, so it's possible also to determine the tension on the cables. And another example would be using it on monitoring of wind turbines, so either onshore or offshore, where the optical technology is quite interesting because fiber doesn't corrode under the wet environment and salty environment, and also has other advantages here on this environment. So summing up, in terms of the characteristics of the sensor for these applications, so the first and biggest characteristic of it is its sensitivity. So the fact that we can measure detailed acceleration levels is very interesting for the ambient vibration and for the monitoring of these large stiff structures. The fact that it is temperature compensated, so this gives stability over time on the measurement and the possibility to measure very, very low frequencies as well. This is highly important as the fiber Bragg rating is quite sensitive to temperature as well. So it's always a thing that we have to consider whenever using fiber Bragg rating technology for this type of monitoring applications. The fact that it is fiber optic, there are other technologies, of course, for the same type of application. But when we are talking about long distances or long structures like you have on big bridges, the optical comes as a preferred choice because of this. The fact that the fiber has low attenuation means that we can address several sensors with the remote locations, in remote locations. Additionally, we can have several sensors in series. This is general for the systems based on fiber Bragg rating technology. And the fact that we can have several sensors makes the full solution cost effective. In particular, our offering is of course compatible with the other HBK offerings, and this means that we can deliver a full structural health monitoring solution, not only the fiber optic accelerometer, but also combined with other sensors from the same technology, and moreover, sensors and other equipments from other technologies that can seamlessly be integrated into full systems. So with this, I come to an end, and I would like to invite you to learn more on our website, where you can also find some documentation to download. And of course, I am available now or by email to answer to your questions.